This is college algebra, and we are continuing our discussion of piecewise functions. Last time we introduced how to graph a two-way linear piecewise function, and then a three-way piecewise function, which included a quadratic equation. And we're going to continue these doodle notes by practicing graphing piecewise defined functions. So here we see we've got a three-way piecewise function, which means that we've got a couple of fences that we need to address here. So we've got three main sections of subdomains, and we're just going to define them down here and then put our fences up. So the first subdomain goes from negative infinity to -1. The second subdomain goes from -1 to 2, and we see that we have parentheses because they're not included. And then the third subdomain goes from 2, including 2, to infinity. So let's draw in our fence at -1. We're going to draw in our fence at 2. Okay, our first equation is f of x is equal to x plus 7. So we're going to start at 7, and then our slope is +1, but I'm not going to graph starting at 7 because that goes past the fence. Okay, but I am going to graph up until the fence, which is -1, 6, and this is included. He owns the fence, so he gets a closed circle. Then x squared is a parabola, 2, 4. He gets an open circle here, closed circle here. So that's what x squared looks like from -1 to 2. And then we're going to graph x at +2 and beyond. So at the fence 2, okay, when x is equal to 2, f of x is equal to 2. And then I go up my slope +1 from there. So here's my line. All right. So here we have very simple three-way piecewise function defined here. Take a moment to pause the video and try out the second example. Okay. So we see that our subdomains for this one go from -infinity to -7, and then -7 to +infinity. So this is just a two-way piecewise function with a fence at -7. So we're going to stick that there. Okay. At -7, if I were to plug in -7 in for x, okay, I would get 14 divided by 3 plus 6. Let's see, that's just a little bit past 1 here, okay? But it would touch the x-axis at -9. So that's kind of my guiding point here. And then he gets an open circle because he doesn't own the fence. -x owns the fence. -x goes through the origin, and then at -7, f of x equals +7. So I'm going to connect the two lines between -7, 7 and 0, 0. All right, the last piece asks us to write an equation for the graph on the right. So we're actually going to need to figure out how to get the equations for each of these pieces, okay? All right, so we can see here we've got two, let's see, we've got a four-way piecewise function. The fence or the subdomain looks like it's at -7. Then we've got another one at -1. And then we've got another one at +5. All right, so we're just going to go ahead and define those right quick. Now, this is a line. So, and we've got 2 points on this line, okay? Namely, -9 and 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. Okay, and then 0. -7, 0. -7, 0. Okay, how can I find the equation of a line between -7, 0 and -9, 6? Okay, well, I'm going to go ahead and use what I know about finding the equations of lines. Okay, between -9, 6 and -7, 0. First of all, I've got to find the slope, 0 minus 6 over -7 plus 9. So -6 over 2 is equal to -3. Does that resonate with what I've got? Rise is 1, 2, 3, run is 1. Yep. All right, now I'm going to plug that into y minus y1 is equal to -3 times x minus x1, so minus a -7. So y is equal to -3x minus 21. So my first piece of my piecewise function, f of x is equal to, is -3x minus 21 only when x is less than -7. Okay, then for the second piece, I've got a quadratic formula. Okay, my vertex happens at 1, 2, 5, -5, 4, 5, 6. Okay, so I can use the vertex formula. Okay, I see that I rise 2, or rise 1, then 1/2. Okay, so this is going to be a little bit tricky to try to get this. Okay, all right, but I've got a few points that I can work with here. Okay, so this is the quadratic. Okay, and some of my values are 1, 2, 3, 4, 5, 6, 7, -7, -4, sorry, -5, -6, that should be negative, and then -2, -4. All right, I'm just going to plug this into my calculator and get the regression. So stat, edit. Okay, I'm going to clear everything in each of these. I've got -7, -5, -2, -4, -6, -4. And then I'm going to calculate, I know it's a quadratic, and I get that my equation okay, is 1/3 x squared plus 3x plus 2/3. Wow, that was really tricky. Okay. And I also know that that's only for the piece between -7, let's see, including -7, x to -1. Sorry, that's overlapping there. Then the last piece goes between -1, 4, and then 1, 2, 3, 4, 5, 1. Okay, so let's find the equation of a line that goes between -1, 4, and 5, 1. All right, so this is the next piece. I need the slope. 1 minus 4 over 5 minus a -1 is equal to -3 over 6, so that's -1/2. All right, now I'm going to take one of these points and plug it into y. Minus y1 is equal to -1/2 times x minus 5. Y minus 1 is equal to -1/2 x plus 5/2 plus 1. Okay, so this is going to be y is equal to -1/2 x plus 5/2. Another way of saying 1 is 2 halves, so that's 7/2. So y is equal to -1/2 x plus 7/2, and that's my final answer. So y is equal to -1/2 x plus 7/2 only when x is between -1 and 5. And then the last piece is down here at y is equal to -9. And that's only when x is greater than 5. Okay. My last part here deals with some dinner fees. We're going to write an equation that models this situation, okay? And then graph the piecewise defined function, all right? So a driver charges $3 per hour for the first 3 miles. Okay, so the first mile, okay, so this is distance in miles. And then this is total cost in dollars. Okay, so this is my y-axis, my x-axis. All right, and then we're going to talk about the driver fees. Oops. Okay, so what would be this function here? Okay, so after 3 miles, or after 1 mile, he charges $3. After 2 miles, he charges 3 additional dollars. Okay, so there's my fence because it changes after 2 miles. Then at 3 miles, he only charges $2 after that. So 3 miles goes up by 2, then the next is up by 2, then up by 2, and so forth. So we have a slope of 3 until we hit 2, then past 2, we have a slope of 2. Oh, I did 2 miles, not 3 miles. Sorry, this should be 2 miles. Okay? All right, so what does this function look like? We've got f of x is equal to 3x at x is less than 2, and then it's 2 times x minus 2 when x is greater than 2. X minus 2 plus 6 when x is greater than 2. Okay? So if you travel 2 miles, okay, what would your total fee be? At 2 miles, it would be $6. Okay? If you traveled 8 miles, 1, 2, 3, 4, 5, 6, 7, 8, what would his fee be? Okay, so that would be 2 times 8 minus 2 plus 6. Okay, 8 minus 2 is 6, times 2 is 12, plus 6 is 18. If you traveled 50 miles, I'm going to plug it again into this same kind of formula. So I have 2 times 50 miles minus 2 plus 6. Okay, so 50 minus 2 is 48. 48 times 2 is 96. 96 plus 6 is 102. Okay, the end.